Now take this question. This is an important question from inverse trigonometric functions. And this question appeared in AP May 23 and also in TS May 23. Very, very important. So first let us take LHS. LHS is tan inverse 1 by 7 plus tan inverse 1 by 13 minus tan inverse 2 by 9. Now we have a formula like if x is positive, y is positive and xy is greater than 1, then tan inverse x plus tan inverse y can be written as tan inverse x plus y by 1 minus xy. This is the formula. Now if the conditions satisfy, then only we can use this formula. So now you see 1 by 7 is positive, 1 by 13 is positive, and if you multiply them, it is greater than 1. Right. So we can apply this formula between these two terms. So it will become tan inverse of 1 by 7 plus 1 by 13 by 1 minus 1 by 7 into 1 by 13. That is equal to tan inverse of 13 plus 7 by 13 sevens are 91 minus 1. So that is tan inverse of, and also you have minus tan inverse 2 by 9 in every step. So minus tan inverse 2 by 9. This is 20 by 90 minus tan inverse 2 by 9. 0, 0 cancel. This is tan inverse 2 by 9 minus tan inverse 2 by 9, which is equal to 0. This is RHS. Now take the next question. Prove that sine inverse 4 by 5 plus sine inverse 5 by 13 plus sine inverse 16 by 65 equals to pi by 2. Now let us take the first term as A. So sine inverse 4 by 5 we are taking as A, and the second term we are taking it as B. Sine inverse 5 by 13 is B. So if we take sine inverse to the other side, we will get sine A is equal to 4 by 5. And if we take sine inverse to the other side here, we will get sine B is equal to 5 by 13. Now we draw a figure. If this is A, sine is opposite by hypotenuse. This is opposite, this is hypotenuse. So the other side will be 3. Now if we draw figure for this, if this is B, again sine is opposite by hypotenuse. Opposite side is 5. Hypotenuse is 13. So by Pythagoras theorem, the third side will be 12. Now after getting the figure, we will find out cos A and cos B. So cos A is adjacent by hypotenuse. So 3 by 5. And over here cos B is again adjacent by hypotenuse, 12 by 13. Now we know that cos A plus B is, what is the formula? Cos A cos B minus sin A sin B. So if you substitute the values, cos A is 3 by 5, cos B is 12 by 13, minus sin A is 4 by 5, sin B is 5 by 13. So this is 36 by 65 minus 20 by 65. That is equal to 16 by 65. This is cos A plus B. So A plus B is equal to cos inverse of 16 by 65. Now let us take LHS. So LHS is sine inverse 4 by 5 plus sine inverse 5 by 13 plus sine inverse 16 by 65. But just now we got the sum of first two terms is it is cos inverse we got it as cos inverse 16 by 65. And the last term is sin inverse 16 by 65. But we know that cos inverse theta plus sin inverse theta is pi by 2. So which is equal to pi by 2, which is equal to RHS. Now take the next question. This is also important. If tan inverse x plus tan inverse y plus tan inverse z equals to pi, then prove that x plus y plus z is equal to x, y, z. Now first let us write down what is given to us. So tan inverse x plus tan inverse y plus tan inverse z equals to pi. Now let tan inverse x is equal to a. So we can write tan A equals to x. Let tan inverse y is equal to b. And let tan inverse z is equal to c. So we can write tan b equals to y. And also we can write tan c is equal to z. Now therefore a plus b plus c will become pi. Or if we take c that side, we will get a plus b is pi minus c. Now let us find out tan a plus b. Tan a plus b is same as tan pi minus c. Tan 180 minus theta is, now we need to, so if we apply the formula for tan a plus b, we get tan a plus tan b by 1 minus tan a tan b, which is equal to tan 180 minus theta is minus tan theta. So this is minus tan c. So tan A is x, tan B is y, tan C is z. So this is x plus y by 1 minus xy is equal to minus z. So if we cross multiply, we get x plus y is equal to minus z plus xyz. If we take minus z this side, we will get x plus y plus z is equal to xyz. Hence proved. Now take the next question. Solve 3 sine inverse 2x by 1 plus x square minus 4 cos inverse 1 minus x square by 1 plus x square plus tan in plus 2 tan inverse 2x by 1 minus x square equals to pi by 3. So first let us write what is the given equation. So whenever solve is given, we need to find out x value. So 3 sine inverse 2x by 1 plus x square minus 4 cos inverse 1 minus x square by 1 plus x square plus 2 tan inverse 2x by 1 minus x square is equal to pi by 3. Now let us put x is equal to tan theta. Then the expression will become 3 sine inverse 2 tan theta by 1 plus tan square theta minus 4 cos inverse 1 minus tan square theta by 1 plus tan square theta plus 2 tan inverse 2 tan theta by 1 minus tan square theta is equal to pi by 3. Now this is sine inverse of, this is the formula for sine 2 theta. And now this is the formula for cos 2 theta. And this is the formula for tan 2 theta is equal to pi by 3. Now sine inverse will be cancelled, cos inverse will be cancelled, and tan inverse will be cancelled. So we will get 3 into 2 theta minus 4 into 2. So here minus 4 into 2 theta plus 2 into 2 theta equals to pi by 3. So this is 6 theta minus 8 theta plus 4 theta is equal to pi by 3. 6 plus 4 is 10. 10 minus 8 is 2. So 2 theta is equal to pi by 3. So theta is equal to pi by 6. So what is x value? X is equal to tan theta. So x is equal to tan pi by 6. Pi by 6 is 30. So tan 30 is 1 by root 3. So this is the solution. Now take the next question. If cos inverse P plus cos inverse Q plus cos inverse R is equal to pi, then prove that P square plus Q square plus R square plus 2PQR equals to 1. First, what is given to us? Cos inverse P plus cos inverse Q plus cos inverse R is equal to pi. Now let cos inverse P is equal to A. So cos A can be written as P. Cos inverse Q is B. So cos B is equal to Q. Cos inverse R is equal to C. So cos C is equal to R. Therefore, A plus B plus C is equal to pi, which implies A plus B is equal to pi minus C. Now if we take cos on both sides, we get cos A plus B equals to cos pi minus C. Now what is cos A plus B formula? Cos A cos B minus sin A sin B. Now what is cos pi minus C? Pi is 180. So cos 180 minus C is minus cos C. Now cos A into cos B I am not disturbing. Minus sin A can be written as root 1 minus cos square A. Then this can be written as root 1 minus cos square B equals to minus cos C. So now we substitute the values. Cos A is P, cos B is Q, and cos C is R. So PQ minus root over 1 minus P square root over 1 minus Q square is equal to minus R. So now if we take minus R this side and the second term to the right hand side, we get PQ plus R is equal to root over 1 minus P square root over 1 minus Q square. So now if we square on both sides, we will get PQ plus R whole square is equal to 1 minus P square into 1 minus Q square. Now you open the brackets. P square Q square plus R square plus 2PQR is equal to 1 minus P square minus Q square plus P square Q square. Now both the sides we can cancel P square Q square. So we are left over with P square plus Q square plus R square plus 2PQR is equal to 1. Hence proved.